Hey stats students, today our goal is that you understand what a residual is and what a residual plot is and why it's useful in statistics. So if you look at this little situation over here, what we have over here is on the x-axis, I have the weight of mixers. And they're kitchen mixers, I should say. So like if your parents or grandma or grandpa, aunt or uncle or someone cooks at home, sometimes I use like a little handheld mixer to mix up the batter. So it's a lot easier than trying to do it by hand, right? And then what we're noticing is as the weight of the mixer increases, this y-axis, the response variable, that is the cost of the mixer. Okay. Now, I know this looks like cosine t, it's cost. I used, software for it, whatever. Don't worry about it, but this is the cost. So here is my regression equation. I have the predicted cost, okay? The predicted cost is equal to negative 20.711 plus 12.533 times the weight of the mixer. So what I did is instead of writing it like this, y hat is equal to negative 20.711 plus 12.533 times x, I put what the actual variable it was in for x and for y, okay? So that's where this equation comes from. So I put all this data in the calculator and I found this equation right here. Okay, so what we want to do here first is we want to learn about residuals. And so here's what it might look like. You might see a problem that says find and interpret a residual for a mixer that weighs 25 pounds and costs $300. The first thing that you need to know is what is the residual formula? And the residual formula is y minus y hat. This is going to give us our residual. Okay, so there's some basic steps in order to figure out what a residual is, okay? Step one. Take the x value from the problem and plug into the least squares regression line, okay? So where is that? Well, we have our least squares regression line right here. And in the problem, our weight of our mixer, our x value is 25 pounds. So I'm going to do that now. Here we go. So the predicted cost is going to be equal to negative 20.711, right? Plus 12.533 times 25 pounds. Okay, I'm going to go to my trusty calculator right here and I'm going to plug that in. Negative 20.711 plus 12.533 times 25. Okay, I can see that right there. I hit enter and there we go. Our predicted cost is $292.61. So I am going to round to the nearest hundredth because it is dealing with money. Give me a second. $292.61. Ooh, I don't like that I went over there. Hold on. I'm all in line. All right, let's move on to step two. Get a new color for us. I'm going to go with green. Step two, we are going, so really quick before we move on to step two, you need to know that this is the predicted cost. We are predicting based off of our data and our least squares regression line that we came up with. We are predicting that if we found a mixer at a store and the price was missing, okay? And the price was missing. We are predicting based off our data and our model that mixer would be $292.61. Okay, step two, we're going to find the actual y value, okay, which is called the observed y. For the given x in the problem. And let's just go ahead and instead of saying actual value, we'll find the observed y value for the given x in the problem. Now, to be really clear, sometimes they give you that observed y value in the problem. And sometimes they give you a table, and I'll show you that in another problem. We have to go back to the table and find that given X and what was the actual observed Y value. So this is what actually happened, okay? So we know that for a mixer that weighed 25 pounds, it cost $300. So the actual observed Y was equal to $300. So this, it gave it to us in the problem, but sometimes it gives us to us in a table. So something like this, where we'd have to go find the X value up here and find that Y value. Okay, next, step 3. We're going to use the formula to find the residual. Y minus Y hat, or we'll just do observed Y minus the predicted Y. Okay, so this is our formula right here. We're going to take our observed Y minus our predicted Y. So our observed Y is what we observed in step 2. Our predicted Y is what we found in step 1. So we're going to subtract those. Okay, so we are going to subtract those, right? We have our step 2, our observed Y, which is $300. Forgive me, I had something wrong there, so to fix it. That's my observed Y. That's step 2, minus my predicted Y. My predicted Y is what happened in step 1, $292.61. I know I'm going to put that in my calculator. $300 minus 292.61, and I get 7.39. Okay, so now we need to talk about what that residual actually means, okay? So what is a residual? I'm going to erase what I have up here, excuse me. What this line is doing, guys, is I could go to a store, and let's say we went to Bed Bath & Beyond, and something happened, and all the prices were not on the mixers. Based off my data here and my model, I could say, oh, okay, I have a mixer that weighs 10 pounds. The model tells me it's going to cost $100. If I plugged it in, I could figure that out as well, but I'm just looking at the line right now to give you a visual. Okay, so this is the value. If I plug 10 into the equation, this is the value that I would land at. Now, this is probably a sketch, so don't take this all for like literal. Don't plug it in. If it's not 100, that's okay. This is all, like I said, just a sketch based off of previous data that I had. So we go into the store. This mixer weighs 10 pounds. We don't know the cost, so we plug it into the equation. Our equation tells us it's supposed to cost $100. We go up to ring it up at the cashier, and the cashier says, nope, it's actually $50 right here. Now, the difference between the observed value and the predicted value, okay, the observed value and the predicted value, that's your residual, okay? That's your residual. So all of these dots right here, these are actually observed Y values, and they all have a residual with it. This distance, because this is what the line for, I think it looks like approximately 26 pounds. There was a mixer that was 26 pounds and it cost $350. But the line predicted it to be about, well, just eyeballing it, about $300. So the residual is telling us the difference. Now you see these ones here, these have little residuals, right? That means the line was doing a pretty good job of predicting. But this line right here, that's a big difference. The line didn't do such a good job here. You see, the residuals have an important, they play an important role in statistics and telling us how appropriate our line is for measurement or prediction, okay? Let's go now to interpreting this. So what happened in this one? What is our residual 7.39 telling us? It's telling us that for a mixer that weighed 25 pounds, The residual is 7.39. Did our line overpredict or underpredict the cost? Well, you can see this one right here. This is my observed Y. And this one right here, this is my predicted Y. It looks like it underpredicted what we had. So the line underpredicted the cost of the mixer by $7.39. Okay, so you can use this to help you. Now, one thing you need to know, anytime we have a positive residual, the model is underpredicting. Anytime we have a negative residual, the model is overpredicting. All right, part 1 of the video, how to find a residual, what is a residual. Part 2, that's going to be what's the importance of a residual plot.